Okay, I've got my wind tunnel here. It's running. I've done my measurements and made my calculations. Over here on this paper, you can see what we're looking at. My calipers that I used were in inches, so I just converted to meters here. We've got the entrance area and the exit area. You can see my wind tunnel. It's not like built exactly, so the exit area is a little bit smaller. And then in order to find the density of air, I looked up some values online for like the atmospheric pressure, the temperature, and the humidity today. They're not exact because it's for Salt Lake, and I don't live in Salt Lake, but I figure it's more exact than it needs to be anyway. And I got a density of 1.20865 kilograms per meter cubed. As far as the airspeed goes, the airspeed going in 5.2 meters per second on average. It's a little hard to take an average because it's not a very large fan. It's yeah, so we're getting somewhere between 5.2 and 5.3 going in, and then coming out we get, when I measured it earlier, I got 5. So let's see, there we go, 5. It's all over the place, but that's close enough. Once you calculate the volumetric flow rate and the mass flow rate, obviously that's just volume over time and mass over time. You get the area times the velocity. Going in, we have 0.7488 meters cubed per second. Going out, we have 0.615 meters cubed per second, and that gives us a loss of 0.01338 meters cubed per second. And then for the mass, we have density of air, that's why we calculated all that earlier, times the area, times the velocity. So here we've got those values, that's going in, going out, and then the difference here is what we have lost. Occasionally when I would measure these, I'd get a faster speed coming out than I did going in, like you just saw in the video. I think that's because if you flip this around, this fan is pulling air in from all different directions, and we're getting the velocity just of this small little cross section here. And then in addition, so we're not getting a very true reading of the velocity of the air coming in. Like if we were to measure it right after it left the fan, it'd probably be a little bit closer. And then also because the area here is a little bit smaller, it kind of funnels the air in, which means the air has to speed up in order to get out. So it kind of depends on where I hold this, how fast it's going to read. It may or may not read faster than the air going in, also depending on where I hold that. So anyway, just something interesting that I noticed.